Nonlinear systems. A system of nonlinear equations in two unknowns is a system of equations in which at least one equation cannot be written in this form. Okay, so that means at least one equation is not a linear equation. The solution to the system is a set of ordered pairs xy that satisfies all equations in the system. And we can look at these ordered pairs to be the points of intersection of the graphs of all equations in the system. We already did this, but what we did was solving linear systems. The methods to solve systems of equations are substitution, elimination, graphical method. But you know what? Sometimes it's not always practical to do it this way, which is why we have numerical methods to solve systems of equations. When we say numerical methods, these are methods that require a computer program. And I can remember my days when I was still a student. We have this subject called numerical methods and numerical analysis. And what we did in those subjects was to create an algorithm, to design a computer program that will solve linear systems and nonlinear systems. Okay, so let us demonstrate these methods. Let us begin by substitution. Let us solve this system. So that is how you write a system of equation or system of equations. Okay, so you have this brace, and then you write your equations. So what do you see here? What do you see? What graphs do you see here? So this one, x squared plus y squared is equal to 10. This one is the equation that defines a circle. Okay, so it has a center at the origin and a radius that is equal to square root of 10. And this one is a linear equation. So in effect, we are looking for the points of intersection. Does the system have a point of intersection, or do these equations have a point of intersection? Will the line intersect the circle? So let us solve this by substitution. So from 2x plus y is equal to 1, we can write y as y is equal to negative 2x plus 1. And so we will use this and replace y by negative 2x plus 1 in the first equation. So x squared plus, so this is y squared is equal to 10. Let us expand that binomial, and it's equal to this. 5x squared minus 4x minus 9 is equal to 0. We can solve this using many methods. We can solve it by factoring, by completing the square, by the quadratic formula. Okay, so it's not always easy to look for the factoring whenever the coefficient of x squared is not equal to 1. But with patience, factoring will easily show you the solution to this equation, okay? Let us verify if this is indeed the factoring of 5x squared minus 4x minus 9, okay? So 5x times x is 5x squared, okay? Negative 9 times 1 is negative 9. And then, this is negative 9x, and then this one is 5x. And so their sum is negative 4 times x. X is equal to 9 over 5, or x is equal to negative 1. Okay? So these are the x coordinates of the points of intersection. X coordinates. Let us now get the y coordinates. Let us solve for y. So when x is equal to 9 over 5, so we are using this equation. Y is equal to negative 2 times x plus 1. When x is equal to 9 over 5, y is equal to negative 13 over 5, okay? When x is equal to negative 1, y is equal to 3. So this is the solution set. And that is how we write the solution set. The solution set contains the points of intersection, and when you have to write the coordinates of the points of intersection, this is how you write it, okay? And then you put them inside a pair of braces. So visually, what this means is your line will intersect the circle, and the points of intersection are going to be these points A and B. Let us solve a system by elimination. So what is this? Okay, so what graphs compose this nonlinear system? So this one is an equation that defines a parabola, and this one is an equation that defines a line. And so we are looking for the points of intersection between a parabola and a line. Will the line intersect the parabola? Let us solve this by elimination, okay? So let us eliminate y. So you multiply negative 1 to the second equation, and your second equation is equivalent to this. Negative 2x plus y is equal to 1. And then we will add the two equations, okay? This one and that one. And as you can see here, this is negative y. This is y. When you add the two, it's equal to 0. That's what's supposed to happen in elimination. You are eliminating one variable. So from a system of two equations, this should bring you to a system of one equation and one unknown, okay? This is the resulting equation. A quadratic equation, that is this the general form. This one can be solved by factoring. And so x is equal to 4 over 3, or x is equal to negative 2. These are the x coordinates of the points of intersection. Let us now get the y coordinates. Let us solve for y. Okay, so let us use this equation, okay? This or this. So when x is equal to 4 over 3, y is equal to 11 over 3. When x is equal to negative 2, y is equal to negative 3. This is the solution set. So our line will intersect the parabola, and these are the points of their intersection.